Perfect.
The lighting's a little weird.
All right, so you have the team members, or at least the team members that'll be traveling to Spaceport, and then also your flyer of record. Are they online as well?
Yeah, John is here.
Hi. Right here. The old guy.
You're the flyer of record?
Yeah, one of them.
So the flyer of record that you guys listed is Shane.
That's
Is
right.
Shane? Okay.
There's three of us looking after 9 Canadian teams, and we sort of share a little bit. So
Okay. So I'm literally just following kind of what you guys put on your Hero X submission. So that is what I can see. So all right. Well, let's get started then, since we got everybody here and we're not waiting on anybody else. So I want to remind you guys, this is not for points, but it is a mandatory event that we have to get this done. You guys have already figured out the recording part, so thanks. This is being recorded. When we're done, just make sure you follow the instructions. They said that they want you kind of record it and take the file, the video file, put it on like a shared drive, like Google Drive or something similar, and then provide them a link. So make sure you do that by the suspense date, which I think is Sunday. I think it's Sunday. But kind of the way that this will go. So I've been kind of tracking you guys and not scoring you guys, but we've been watching you and grading your submissions and giving you feedback throughout the year. This will be the final event, before we actually go out to Spaceport. Essentially, they've given me a checklist, and I will run down a checklist that basically takes walks through the rocket from tip to stern. And we'll look over it. I'll ask you some questions, and then at the end, you guys can ask me questions. Really, you can ask me questions during the event itself, and then at the end, once we're done talking about the rocket, I want to talk about what to expect out at Spaceport. Have you guys been at Spaceport before, or is this your first time?
Some of us have, yeah.
Okay, roughly how many members of the team have been out to Spaceport before?
1, 2, probably 5.
Yeah.
And how many are going?
14.
14. Okay. So that's good. That's great. You have some experience of what to expect out there. But I'll cover a few little things, kind of the gotchas and the high points that they probably told you last year, as well as a couple things that'll be different this year. All right. So before we get rocking and rolling, do you guys have any questions for me?
No.
Okay. Do you have a presentation that you plan on giving? Some of the teams have given me a presentation that they run through, but it's not mandatory. I'm just trying to figure out exactly what the best way to proceed would be.
We don't have a presentation. I think we were just going to walk through from each of the sub teams, I think, and then cover everything.
Okay.
I don't know if you have a different plan.
That sounds great. It's actually a little bit faster doing it that way anyway. So let's get started. So let's start with the nose cone. So remind me, what did you guys do for the nose cone? Is this commercially purchased, or did you fabricate your own?
Yeah, so I actually have all our parts here. The nose cone is not yet fabricated, but we're using a 3D printed male mold. So this is the inside, and then 2 of the outside pieces will sort of clamp around like this, providing some compression. And we did a similar method last year that turned out really well. So we're doing that again, I believe either this or next weekend, in terms of manufacturing that. Yeah, we use a Von Karman curve, and the nose cone itself is about 80 centimeters long.
Okay. So we're about a month out from launch, and you guys still don't have a nose cone. So if it doesn't go well with your your layup and your manufacturing the nose cone, do you have the ability to purchase a commercial one?
Yeah, so we actually have one from last year that we didn't end up launching. So we have the same body tube diameter, so that should be fine.
Okay. Good. At least you guys have a backup in case, something goes wrong or it doesn't turn out right. Sometimes bubbles or cracks or when you're making your own composite tubes and composite parts, these are not simple things. So you know, just as long as you guys got a backup. So is it intended to have be completely fiberglass? How are you going to handle the tip? Are you going to fill the tip? Is it going to be metal
Yeah.
tip?
So it'll be an aluminum tip. This is from 2 years ago, Rocket, basically the same sort of thing. It'll have a threaded inside here, and then there's a little bore out here. So if I take this nose cone mold, you want to hold the back end of that? And it'll just basically fit on like this. That bore, or like that little extrusion, will catch it. And then on the inside, there will be a threaded rod, a little 3D printed spacer, and then a washer and a nut holding it on the other side. And it'll also be epoxied in place.
Okay, threaded rod as in like a steel or a metal rod at least?
Yeah, yeah.
Okay.
That'll be threaded in the middle there.
Okay. And remind me, you guys are 10K cots?
Yep.
Okay. You guys are like, I've got like 10 teams I need to do interviews with, and you're like the 6th or 7th I've had. So things get jumbled in my brain this week. Okay.
Yeah, no worries.
So just bear with me. So if I'm asking really basic questions that you think I should know, just understand that this is like the 4th or 5th interview in like as many days that I've had.
Yeah, no worries, no worries. I've got all the
Okay.
info here, so I should be able to update you.
Okay, so let's say your nose cone goes together great, everything looks great. What is your planned shoulder length for that?
Yeah, our shoulder length is 25 centimeters, and that's to accommodate our 3U payload. This is a little shell we 3D printed. That's not the actual payload interface. Cams
So
are payload.
What I'm really after is what is your engagement between the nose cone and the separation point? So there's gonna be a separation point between when your nose cone fits the rest of your body tube, and then you've got your nose cone coupler there. How long is that relative to your body tube? Is it at least 1 caliber? Is it half a caliber?
It's 1 caliber.
1 caliber. Okay, very good.
All our extensions are 1 caliber at least.
Okay, very good. And so your payload's going to go into your nose. Is that what you just said? So how are you going to secure the payload, and how are you going to secure the nose cone itself?
Yeah, so the nose cone will have obviously a coupler inside extending 1 body caliber each way. The payload will be mounted to one of our aluminum bulkheads, and then that will be screwed in from the outside. And then the other side of the tube itself will also be screwed into the other side of the coupler, if that makes sense.
Okay. Yeah, so I'm trying to do without, usually what we do is we have you like lay out the physical components so I can look at load tracing. So now I'm trying to do load tracing in my mind of what your plan is. Like, so we identified a team yesterday that had poor load tracing and were most likely going to fail at the field. So we told them to go back to the drawing board a little bit and make that part of the component more robust, because they basically had a little bit of a lip that was fiberglass that was most likely going to break. So talk to me a little bit about your plan. Okay, I see you've got a coupler. Okay.
Let's say there's a nose cone above here.
Okay.
And this is the main chute tube here. So we have I think it's 1.4 centimeters to where our holes are on either side. So the payload will be here, and then our don't know if it's shear pins or screws, but yeah, they will be here on 1.4 down.
Okay, that distance is good, but it will matter what you use and like what your material is to secure those. So shear pins are intended to break, obviously. Screws are not. But even then, if you have screws that are too small of a diameter or not enough of them, what can happen is you basically just tear a line through your fiberglass and the whole thing comes apart, which is what was going to happen with the other team.
We have 5 M4s on every joint.
Okay. Those are pretty big. Okay, very good. All right. And you have your payload in the nose cone. And is the plan to have the main parachute below that? Is it, what I'm getting at, is it the nose cone getting ejected, or is that staying in place with that upper body tube?
Yeah, so the nose cone itself is not getting ejected. It's main chute, avionics bay, drogue chute.
Main chute, avionics bay, drogue chute.
Yeah, yeah.
So is it all one tube, or like are you breaking in half and then two pieces tethered, or are you all your drogue and your main coming out of the same tube?
Drogue and main are separate tubes, so the avionics bay is in the middle and separation will occur on either side of the avionics bay. Main
Okay.
above, and then avionics bay.
Okay,
And
so
then
pretty standard deployment.
Yeah.
Okay, very good. And then I know you're still working on it, but you showed me that metal bulk plate. How are you going to attach to make sure that your nose cone just with your payload just doesn't keep going? Do you have a U-bolt? Do you have an I-bolt?
eye bolts on our recovery connections, yeah, to the bulkheads.
Okay. Are those forged bolts? Are they welded at all? Are they U-bolts?
Yeah, they're eye bolts with a strength of 1,300 pound-foot.
Okay. That will probably be sufficient. Okay, very good.
Yeah, we've done our shock load calculations as well and consulted with our mentors, and they're happy with that as well.
Okay, very good. So we're talking about recovery. I'm moving on to recovery now. Shock cords, how long and what material are they made of, and how thick, how big?
Yeah, they're 30 feet of Kevlar, and their rated strength is 8,600. I believe they're around a centimeter thick. Russell, do you have that on you?
So
Yeah,
centimeter. Go ahead.
around a centimeter. Don't have an exact measurement on me, but around a
Yeah,
centimeter.
they're Rocketman rated Kevlar shock cords.
Okay. Are they tubular? They're Kevlar, so it should be fine no matter whether it's flat or and it's like it's basically about like your fingernail. That's about a centimeter, right?
Yeah, yeah. Sorry,
Okay.
Canadian.
It's okay. It's okay. Very good. And then so 30 feet on both ends, both for the drogue and for the main.
Mhm.
Okay, great. That's plenty. What size is your main chute?
Our main chute is 94 inches and sorry, 96, and our drogue is 24.
96. So that's
8 feet.
it's 8 feet.
Yes.
8 feet. And like what is it? Is it a panel chute? Is it a hemispherical chute? Is it got a spill hole?
Yeah, it has a spill hole.
So is it hemispherical with a spill hole?
I believe so. Russell, do you have the chutes up?
My computer got water damaged about 15 minutes ago, but they're toroidal.
Okay.
Toroidal. So that's the Rocket Man one. So are they not?
They're fruity chutes.
Fruity shoots.
Oh, fruity shoots. Okay. And what's your expected descent rate under the main?
19.4 feet per second.
Okay. And what's your overall weight?
34.75 pounds.
Is your overall weight of your rocket?
Yeah, that's wet. With like propellant and casing.
34 pounds?
Yeah.
With an 8-pound payload?
Yeah, including that, yeah.
That is really light. Have you actually weighed the components to make sure that's accurate?
Yeah, other than the nose cone, which hasn't been made yet, for that, just using the same expected volume and the density as the carbon fiber tubes. All the tubes have been weighed. Payload hasn't finished being made yet, but the mass for that and the mass budget's just 8.8 pounds.
We're if anything, the payload will be under. We're just gonna have like masses spread out to reach the 8.8.
Okay.
You're
So-
using a 3-grain motor, aren't you?
Yeah.
A small
what?
motor. 3-grain.
Mhm.
It's a small end.
Small M. Okay. I mean, as long as it's that light, and I'm surprised because you're about half the weight of most of the rockets that that we're seeing out there.
That's what we've seen in the past too. We're usually a little shorter and a little lighter
Yeah, I think part of it's manufacturing our own body tubes.
Okay. Okay. Well, I mean, if that's what your weight's going to be, then your parachute sizes seem fine.
Yeah,
And
Julian's done a pretty extensive mass budget, so I would say we're confident in those numbers.
okay. Just I mean, obviously you will, but you know, before you fly, just make sure that once you get an all up weight, you know,
Yeah,
you
of course.
you make some adjustments if necessary.
Mhm.
Have you decided? I know we talked a little bit about shear pins before, but they're up on my list now. So have you decided on what shear pins and how many and where they're going?
Yeah, so that has to undergo further testing, but right now we have 4 M3s set out. They're nylon. But yeah, once the bulkheads get finished, we will test accordingly. We've done initial separation and just ignition tests based on what we've had in the past for rockets, but haven't actually like tested this system as the bulkheads are not finished yet.
Okay.
We will be doing extensive tests once those finish, which should be in the next week.
Okay. Because I saw on your posts, it looks like you did some testing, but it wasn't the true separation testing. You were just firing the charges to see if they worked.
Yeah, it was more just getting acquainted with our packing system again. We've had some turnovers in leadership, as well as facilitating knowledge transfer to our recruits. But yeah, since we didn't have our whole flight setup ready yet, we haven't done that full separation with the new bulkheads.
Okay. That'll be important. I mean, you guys know this isn't your first rodeo. Yeah, it's a mandatory thing. And even if you can't get it done before you get out there, you can still do it out there. Most international teams are, you know, about half of them are doing it out there because of the restrictions at their home countries with black powder and things like that. So if you have to do it out there, there'll be opportunities. And it is black powder. It's not a CO2. That's what you're planning on using?
Yeah, 3F black powder.
Okay. Not Pyrodex, the actual no kidding black powder.
No, yeah, we have 3F here, and that's what we plan on getting at competition. We made sure that it would be the same in both places.
Okay, great. Yeah, because the Pyrodex usually needs a bit more compression. You need a little bit more. It's a little bit different than black powder. It's not a 1-for-1 swap. Okay. Talk to me about your protection. You really don't need protection for your shock cords because they're Kevlar, but talk to me about what you're doing to protect your chutes from those charges.
Yeah, we're using Nomex blankets for those, and they'll be tied to the shock cords.
Okay, very good. Not using deployment bags or anything like that, just the Nomex blankets?
Yeah.
Should be fine. And then how are you connecting your shock cords to your hard points, like your eye bolts? Are you using quick links? Are you tying them directly or using something else?
Yeah, so the shock cords that we buy from Rocket Man come with like sewn 1/3, 2/3 connection points for the chutes. And then from the actual shock cord to the hard point, it'll be eye bolt, quick link, swivel, quick link, swivel. Is that correct, Russell? Or maybe I have one too many.
But it's tied to the eye bolt and then shock cord and then quick link, swivel, parachute.
Okay.
So that's for the main. What about the drogue? Or is that for both? Okay. Very good. Yeah, I like the fact that you got a swivel. Some teams don't think about that, and usually on the way down, your back end is spinning a lot. So sometimes what will happen is that will wind up and it will bring them together and they'll start banging on the way down.
Yeah, we don't want to clacker, that's for sure.
Yeah. All right. And then vent holes, have you thought about that? Do you know what your plan is for the vent holes for both your altimeter and for your main bays, like for where your drogue and your mains are?
For the avionics bay, we have static portholes planned. Our avionics lead is currently on vacation. Do you have the holes?
He sized them for modern high powered rocketry 2. I can't think of the holes for this static port.
Say it again. I didn't get that.
Yeah, so they're sized based off the textbook reference Modern High Power Rocketry 2. We're just actually pulling up the whole size themselves right now.
Diameter
Okay.
is 0.95 inches.
0.595 inches.
0.5.
Diameter.
Gonna upsize it to, 1/8 inch.
Hmm?
Gonna upsize it to 1.
Okay, we're upsizing to an 1/8 of an inch.
1/8 inch drill bit.
An
For
1/8 of an
standard.
inch or half an inch? Because 0.5 is half an inch. Or is it 0.5 centimeters?
1 second, sorry, they're just looking it up.
Because what's the diameter of your rocket?
5.5 inches.
Okay.
So give that spread across the whole.
Okay, so we're gonna have,
Three tubes that we're talking for that.
okay, we're gonna have 2 static portholes. So, sorry, if it was 1 static port, it would have been 0.595. We're gonna have 2 static portholes. The recommended value from the textbook would have been 0.099, which we're sizing up to an 1/8 of an inch.
Okay, 2 stack holes of an 1/8 of an inch each.
Of 1/8 of an inch?
Yes.
Probably insufficient from my experience. So I have a 5.5 inch rocket and I have 6 1/8 inch holes around the for the avionics bay is what I use.
Sorry, could you repeat that?
I have 6 1/8 inch holes on mine around essentially what is my my switch band. 2 1/8 inch holes for a 5.5 is going to be a safety issue.
All right. Okay, we will, yeah, we'll update that
Because
to,
you're not going to equalize fast enough. That's too much
Okay.
space in there, and it's too much volume of air, and it's not going to get out fast enough for you to get an accurate estimate. It probably would be fine near apogee. You would just get potentially weird data, and I definitely would advise against using a single porthole. What altimeters are you using?
the Featherweight Blue Raven and then Altus Metrum Telemega as the redundant.
Okay, both of those use, I think, acceleration to detect liftoff, so you would probably be fine. It can get really windy out there, as you know, and if you have a single porthole that's really, really big, a lot of times you're going to get pressure fluctuations as the wind goes across that hole. And if you have a barometric-based altimeter, it could, you know, trip it and make it think that it's flying when it's really not. So that becomes a safety issue.
So our bay itself is like it's a sled, so one like the main's on one side and the redundant's on the other. Would you recommend spacing the holes all the way around or just one like a couple on one side, a couple on the other?
Typically, that's what we do for the safest thing is because
Okay.
usually what happens is if you've got wind on this side and it's causing a pressure differential, the holes on the other side provide that equalization. So you don't get as quite of a buffet in the middle for the altimeters. John, what would you say to that? What do you think?
Yeah, I would say the same thing. I think you better look at the altimeter manufacturers' recommended hole sizes as well. I know I fly a lot of stratologgers and their holes are a lot smaller. Their requirements are a lot smaller. But I do fly Telemega as well.
Okay. Yeah, we'll definitely look into both your recommendation and yeah, the altimeter regulations as well for those. And we'll run them by you before we make any finalizations.
Yeah,
Just
work with you. Go ahead, John.
Just those altimeters are mounted vertically, aren't they? When the rocket's vertical, because they have to be mounted vertically.
Yeah, they are.
Okay. Just
I actually, the sleds are right here, so.
Okay.
Sleds with an S. So I see 2. So
Yeah,
talk
so
to me about how that goes together.
Yeah, so what we have in the middle will be a 3D printed spacer, which will house 2 threaded rods, which is how we're interfacing with our bulkheads.
Okay.
So they'll be like this. And so we have our switch risers to make the switches easily accessible to the surface. And then we also have our fiberglass tube and associated couplers, 1 caliber in, for RF permeability as well, or transmissibility.
Okay. So talk to me about the orientation. So it looks like you guys, I see a big spot on that sled for what I'm guessing is batteries. Is that going above or below, or what's the actual orientation?
Yeah, so this will be the orientation for 1 through the battery.
Okay,
Is that battery attached?
that was gonna be my next question.
No, these are, I don't know what these, yeah, I'm not.
They're battery holders, so the batteries are gonna be like secured in those holders. And there's a panel, so you would close, like there's a panel that goes above the batteries to secure the batteries within the two, like
So
I'm not sure-
what are your batteries? Let's start there.
they're the standard
Manufacturer
3.7. Yeah.
So they're the LiPo
Yeah.
from the manufacturer
Yes.
from manufacturer. Yeah.
for both.
Yes.
Okay, very good. And both of those have a secure little plug on them to where it's not going to rattle loose or come loose with acceleration or anything like that.
Yep.
Okay, very good. So yeah, as long as they're not going to break off the board or slide down or anything like that, they should, whatever you do for that, it should be fine.
Yeah, the
batteries
holders are
fully
screwed.
contained.
Yeah, the
screwed.
holders are screwed in, so they shouldn't be able to move.
Okay, great.
Yeah. You can see. Sorry, my camera quality is terrible, but if you can see that.
Okay, that makes more sense now that's what you said. You've got a little enclosure that basically keeps it in place so it can't go anywhere.
Yeah, they're enclosed on all sides,
Okay,
except for this little hole for the terminals to come out.
and then for what looks like, what's your GPS device there? Is that a featherweight?
That's it. Yeah, the featherweight GPS.
Okay, and what's the power source for that?
I believe it's also manufacturer provided. I'm not sure on the exact specifications. Lucy, do you have that?
I'm pretty sure it's either the 3.7 or the 9-volt standard battery. I'm pretty sure it's the 3.7 volts as well, though, the LiPo. And
Okay.
it's manufacturer provided. All of our batteries are sourced from the manufacturer for both the flight computers.
Okay, very good. What I would say is that if you are using a 9-volt, we want to see the snap-on clips versus something that's more like the spring type. Spring types can come loose under a G load or make a momentary disconnection and open the circuit. So those are going to be a safety issue that it's going to get flagged at RSO and they're going to send you back.
All right.
And tape the snap-on clip as well with electrical.
Yes.
Okay, very good. And then so you've got the Telemega and you've got the featherweight. So talk to me about your frequency management plan.
So we're going to be using our primary is going to be the featherweight system, so the Blue Raven as well as the GPS module. So that operates on the 900 like megahertz frequency, whereas the redundant one, which is the Telemega, actually operates on like the 438 or the 430. So there's no like interference between them. Regardless, we're only transmitting from the featherweight or like our main system and not the redundant. So there shouldn't be any issues in terms of.
So you're only using one frequency, and that is the featherweight.
Yeah.
You're not going to, because I was going to ask whether you have a ham license to use the.
We do have one on the team. Well, I do, and so that shouldn't be an issue. But again, we're not really transmitting from the redundant. That's only there for the flight data, and then our main one is going to be the one that's transmitting all the information to our base.
Okay. I'll throw it out there. If you decide, I can't tell you what to do, but if you decide you want to use both, that's something you can handle with the frequency management folks on the first day with DaVinci. I think that's the company that they typically use out there. And so you just let them know that you want two, one on 900, one on the 400, and then work with them to do whatever they need you to do. Okay, but it looks good.
How do you keep the Telemega from not transmitting? Or from
we just don't have an antenna, like we're just not putting an antenna on it.
Okay.
That it won't work. You have to make sure it's not transmitting at all. Is there a setting you can turn it off?
I think there should be on the Altus Metrum application where you like configure all the settings. But we'll take a look at that and just confirm just in case.
Yeah, do that because what can happen is if it is transmitting and you've got other teams on that same frequency, you're going to interfere with them.
Yeah, that's true. Yeah, so we'll just try to see if we can turn off like the
Yeah.
transmission. I think there should be a setting to do that. Yeah.
Would it be worth it to just go and get like the frequency management team to just have both of them for us as a fail-safe sort of thing, so we aren't impacting other teams, or is that not allowed even if we choose not to transmit?
That's up to you guys.
Okay.
So you guys got to make a decision on whether you're going to use one or two. You can certainly you know, ask to use two. There's a lot of teams this year, so it depends on how crowded the bands are. So but I would caution you from just, hey, we'll be okay by removing the antenna, because that might not necessarily be true. Because it can, even without antenna, it can still transmit a fair amount of RF energy. And remember, if you remember last year, they have you do multiple radio checks. So before they will go, once you get the rocket up and it's on the pad, they make you do a radio check. And if the team next to you or a team nearby is on a similar band, you're going to interfere with them. And so they're going to fail their radio check because of you guys.
You might be able to shield it as well, just by putting a little Faraday shield around it, metal shield.
That's true, but the best option is, if you're not going to use it, is to turn it off, turn the feature off in the hardware settings or the software settings.
Don't know that you can.
Oh yeah.
We'll just try and see if we can like maybe transmit from both just as again like a fail safe. I think that would be a good idea.
That sounds good to me.
Quick question about that. Do you have any like, do you know when those forms or frequency management, like when DaVinci will be reaching out to us?
You do it at check-in.
Oh,
that's
okay.
how they were doing it last year.
Last year they sent out forms for us to like kind of for like all of our like walkie-talkies, all of our flight computers, to like a lot like our frequencies. I don't know if that's changed, but that's how it was.
Yeah, I didn't see, you know, I was expecting something similar this year because I think they did it last year, like in the Hero X, like in your submission.
Yeah.
But I didn't see that this year. So maybe that's something worth following up on. I don't actually know the answer to that one. So since you potentially need two, it would be something worth asking.
Yeah, for sure.
Good point there. All right, so I'm going to move to the next section. I'm sorry it's taken so long, but you know, we're covering good stuff here. So talk to me about your body tubes. I'll move on to the body tubes. They're made of fiberglass. Did you procure them? Did you make them? I think I saw you guys doing some compression tests.
Yeah, so everything will be carbon fiber except for the avionics bay, which will be fiberglass with fiberglass couplers. They're 7.3 ounce bidirectional twill. And we roll up on what I call like a dual coupling system. So it's a wet lamination. So we impose tension to try and mitigate those air bubbles and any other impurities that can get in as you're doing a wet layup, because it's not as pure as like a vacuum would be. Because we do that, we have compression tested accordingly. Do you have the factor of safety on you, or? But yeah, adequate factor of safety, I believe around 5 for the carbon fiber and around 10 for the fiberglass.
What was your reference point for the factor of safety? Was it the thrust of the motor, or was it
maximum
thrust transfer through that part of the rocket? So for the carbon fiber one, because the carbon fiber is the bottom body tube, it would have been thrust to transfer the whole weight of the rocket except for the motor. And then for the avionics, or for the fiberglass ones, it would have been to transfer the weight, everything from the avionics bay and up.
Okay. So what I think I heard was you guys thought about your main chute opening, which is actually the biggest acceleration event of the entire flight, and that you've thought through that, and they're strong enough to hold up and hold the weight of the rocket, and you're not going to have, you know, screws tearing through that fiberglass and that carbon fiber. Is that correct?
Yeah.
Okay. Yeah, if you didn't know, or if you don't have team members that know, Yeah, that main opening event is typically the largest shock, and you can see anywhere from 20 to 30 to 50 to even higher G loads. Momentary, of course, but G loads that significant nonetheless. So that's usually where we see things, if they haven't been manufactured strong enough, that's usually where they fail. All right. Let's talk about couplers. So you showed me some of the couplers you had already, same material, they're pretty tight. So what's your tolerance between your couplers and your, yeah, show me how, okay, that looks good.
Yeah,
Mostly what we're looking for is
it's
very
friction
good,
fit.
good. The biggest concern here with the couplers, especially ones that are manufactured, is what I call banana rockets. What we don't want is so much slop in those couplers that your rocket's kind of going up like this and thrusting, because if it gets, you know, in a banana shape, a lot of times that's usually when they fail, they bend in half, break in half, and then you end up skywriting.
Yeah,
But what
yeah,
you just showed me looks pretty good.
yeah, I spent a lot of work on the lathe tolerancing a PVC pipe and then to get it to fit like almost like close to interference, but
And then the same thickness and same safety factors on the couplers as the airframe itself.
yes, yeah, yeah, we've tested both.
And then I know you already told me, but just to verify, you guys have at least one caliber, one body tube diameter of engagement on both sides of the break points, correct?
Every joint is at least one caliber, yeah.
Very good. And then, yep, we talked about your shear pin plan, which sounded sufficient. We talked about batteries. We talked about avionics already. Okay, let's move on to the motor. So let's talk to me a little about your motor.
Yeah, it's a M2505. It's from Cesaroni. We're buying from Animal Motorworks, so it'll be delivered on site at competition.
And he confirmed that he has one for you.
Yes, yeah, like months ago.
Okay, very good.
Yeah.
Have you built it before? Have you built motors from Cesaroni like that before?
Yeah, so I built a 3-grain 2 years ago, and then Dylan built the 3400 we had last year.
Okay. 98 or 75?
98.
Okay, very good. And then what's your thrust to weight ratio on that one?
Thrust to weight ratio is 12.2.
Okay, very good. That's what I like to hear. I've been hearing teams around 5 and 6, and makes me a little nervous. You guys are good on that. All right. Payload. So talking about your payload, are you just using ballast, or do you have actual experiment inside?
Yeah, so Cam is our payload lead here. He's right beside me, so you can talk a little more about that.
Yep, so we are doing an experiment. So pretty much we're putting a like miniaturized integrated bioreactor into it to test if it will stand up.
What's a bioreactor?
Pretty much just like an enclosed chamber for that biological reactions can happen. So it pretty much it maintains this constant environment in terms of like the oxygen and pH and stuff. So
I'm just curious, what reaction are you hoping for?
so we're actually not going to run a reaction reactor. What we're testing is the stirring while it's in free fall. So we're comparing 2 different stirring methods to see which one is better under microgravity. Because the idea is that it's testing if you were in space, for example, you don't have gravity-based convection. So if you just have like an impeller at the bottom, it's not gonna agitate all the way through, like for example, a big vat. So we're trying kind of this flexible stir that will go like the entire cross section to compare to see if under the momentary microgravity conditions, it will like perform better. And at the same time, if the sensors of the system still operate and don't just give like haywire information to get feedback if there was an actual reaction happening, if we could still monitor it, or if it needs, you know, more intense sensors or more protection or something.
Yeah,
Interesting.
yeah, prepping for those initial like vibration conditions on if we were going to launch a bioreactor into space, and then also yeah, testing that stirring mechanism under microgravity, as Cam mentioned.
Wow, that sounds interesting. So make sure you guys highlight this when you have your poster competition, all right?
Yeah,
This is
yeah.
one of the more interesting ones that I've heard of. So since you're looking for microgravity, so are you ejecting the payload and it's going to come down independently, or is it going to be all tethered together with the main body of the rocket?
It'll stay contained within the nose cone, yeah.
Okay, very good. So you don't need to worry about secondary GPS devices or secondary parachutes or anything like that.
Nice and simple.
That's what I like to hear. All right, and then how are you containing that within the rocket? You said it's going to go in the
So-
nose cone.
Yeah, so pretty much we have a 3D printed frame and a series of 1Us that slot together, and then each one is fixed along at each of the midpoints with M4 screws. So we did initial testing, compressive testing, and the factor safety was what, 1.3? Yeah, the factor safety was 1.4 around, I believe. But this actually isn't our final material. This is just like PET G with a 20% infill. So I'm gonna reprint it with a carbon fiber nylon to see if we can get even stronger. But initially, just based on like this test, should be good. But
Yeah, and then interface to the actual rocket itself, again, it'll be mounted to a bulkhead like this with 4 screws? 6
Yeah,
screws?
4
Yeah, 4 screws, and then this will be screwed into the side of the nose cone like we mentioned earlier. With that little demo that I did, but I can do it again if you need a refresher.
Okay. It'll be, since I can't see it now, these are things that are going to be covered when you actually do your safety review at Spaceport. So make sure you cover this and cover load tracing with them when you do your RSO review. It gets really, really busy out there, and they see a lot of teams. So make sure you highlight that particular aspect of it, and so that that they understand it and that you're communicating clearly with them. All right.
Mhm.
All right, that sounds good. I'll move back down to the fin can and the propulsion section of the rocket. So do you have that built? Do you have the fins? Do you have something to show me?
Yeah, so I'm going to do the fins after this meeting. But what we have is Nomex foam core, fiberglass frame. They are tapered to an airfoil, and then they are vacuum infused. These are them just trimmed but not sanded to actual length. I know the lighting is terrible.
No, I see it. I can see it.
But yeah, so I'm going to go sand those, and then our attachment mechanism is Giorgio actually just milled a little jig, so we have equidistant spacing for all 3 fins. They're attached and clamped. Basically, it's a horizontal plate and then 3 MDF little spacers. So we'll clamp to those as we apply our JB weld to that initial connection to the rocket. And then we have polycarbonate fin fillets that will carbon forge around a little bit, and then a tip-to-tip layup from each fin.
Okay, so are they going surface mount, or are you going through the wall to the motor mount? Do you even have a motor mount?
Yeah, surface mount.
Surface mount. Okay. That sounds all fine, especially if you're going to do a tip-to-tip with those fillets you described. That sounds sufficient.
Okay.
Just be careful with you guys are young. I'm putting my dad hat on here. Just be careful when you're playing with carbon fiber. Don't inhale. Make sure you got ventilation.
Yeah, we got respirators. Yeah.
There you go. That's what I was hoping to hear. Great. Okay. What is your stability margin again?
Stability is 2.01 at rail clearance and 3.4 during flight.
Okay,
During the
very good.
Yeah.
Perfect. And you're only going 10K COTS, so I'm really not worried about fin flutter here because you're staying subsonic, I assume.
Yeah, Mach 0.97. So
Yeah, you'll be fine, especially with the fins that you just showed me. You have
we
a
have fin
motor.
flutter if you want to hear about it, but
So what?
we have done fin flutter calculations and they all
Yeah,
look
tell
good.
me.
Giorgio? No, I thought you were. No? Okay, maybe we don't have numbers right here, but Giorgio, has done his fair share of fin flutter calculations.
Fin flutter velocities, 3,152 feet per second. Our expected mass velocity is 1,038 per second.
Yeah, you guys are well underneath that. With the thickness of the fins you showed me and the fact that you got carbon fiber layup on top, yeah, I'm really not worried about it. It's plenty sufficient for the flight that you guys are flying. Talk to me a little about, so do you have a motor mount in the rocket?
Yeah, so actually trying to think of how to show it best. I don't have a picture of it. But yeah, we do have like a thrust plate that will be epoxied in place on the end of the motor tube. And then on top of that will be the retaining ring that's COTS from Cesaroni, just like the little threaded ring.
Cesaroni, you mean Aeropack?
Or yes, yeah, my bad.
Okay, very good. Yeah, that was hoping here. So you've got an Aeropack retainer on the back, so that'll be just fine. Is your shock cord where it attaches to the back end of the rocket, the booster, the aft can, is it attaching directly to the motor, or do you have another system that it's attaching to?
Yeah, so above our motor tube is our air brakes module actually. So there will be another bulkhead above that, which is where the shock cord will attach. So not directly to the motor, no.
Okay, so how is that all held together?
Yeah, so the motor itself or
No,
the
so what I'm really interested in is the load tracing. So it sounds like you've got multiple breakpoints. So you've got attachment of your shock cord here, you've got multiple breakpoints, and then you've got that heavy motor down here. So what is preventing all this from coming apart when your main opens under, let's say, 50 Gs?
Yeah, so our air brakes and our parachute tube are one tube together. So that one breakpoint would be where the motor tube connects to that upper tube. And it's, yeah.
Oh, so it's all one. It's all one continuous tube?
One tube, and then air brakes and parachute tube are another. Or, yeah.
Yeah, so there's like for the thrust transfer or for the transfer at main deployment, like the drogue's already going to have deployed. So it's not going to be a solid body at that point because the drogue's below the main. So it's already going to be like attached on the shock cord at like everything from like bottom of the avionics bay and below is going to not be the same solid body as the main when it's deploying.
Yeah, so our main deployment, the highest shock load will be like the main is here, the avionics bay, the drogue chute, and then the motor is below that, if that makes sense. Yeah.
Yeah. But still, it's that main parachute, that big parachute opens up and stops everything. You've got a Kevlar cord that's doesn't have a whole lot of give. Even though you have 30 feet, that helps. That load, so you get this big slug of metal, which is your motor case, that's going to want to keep going down. And then presumably you've got an upper tube where your drogue was and a lower tube where your motor is. What prevents these two from just coming apart when
it'll be the same eye bolt connection that we described before. Is that what you're getting at?
Right. So you've got an eye bolt to here,
yes,
and you've got a bulkhead in this section where your drogue
yes,
was. So let's say it's down here. All right. But this is a separate piece of airframe from where your motor is, which
yes,
is and so these two, when they go together, how are they held together? Because you've got your shock cord here attached to this part. This part's going to want to keep going down. So you're going to have a tremendous amount of force, momentum from your heavy motor case pulling you down. So is this epoxied in? Is this part got screws? Is it got a coupler of its own? Talk to me about that.
For the thrust plate, yes, or just like the body tube interface. Sorry, it's hard to describe with hand motions.
Yeah, and it's hard because you guys don't have it built. Otherwise, I could point to it. Do you have an open rocket file that you send me?
I can pull up an open rocket and screen share it.
Yeah, that would be helpful.
Because if you're talking about
Is it how the motor is contained within the tube, like how it doesn't fall out when that shock load happens?
No, I'm not worried about the motor itself falling out because you've got a commercial retainer. What I'm worried about is that lower part of the airframe breaking away from where where that bulkhead is at.
Yeah, so between each airframe connection, it's screwed like coupler, one body caliber each way, and then it'll be 5 screws and 5 screws. So like 10
Oh.
total holding those two pieces together. That's what you're getting at.
Or like the factor of safety on the bulkheads from FEA, is that kind of what you're? Sorry.
Yeah. So hang on, give me 1 second. I'll show you exactly what I'm concerned about.
My team's so slow.
You have air brakes, do you?
Yes, we do.
So what's connecting the motor, the fin can to the air brake tube?
Yeah, so the motor tube itself is self-contained, and then there's a coupler, one body caliber each side, and then it will be our air brakes and chute tube together.
That's what he's concerned about, is that coupler.
Okay, yeah, it's one body caliber each side. There'll be 5 screws into the bulkhead and then 5 screws on the other side
Yeah.
of that tube connection, all M4s.
I think that's what he's trying to get at. That's what's
Okay,
holding
yeah.
the fin can to the rest of the rocket.
Mm-hmm. Yeah.
Oh, there we go.
Oh.
All right. Yep. This is exactly what I was thinking. Okay. So
Can you see my mouse? This interface here?
yeah.
Yeah, so that coupler is again one body caliber each side.
Yep.
Okay, it's longer on the air brake side than one body caliber. But 5 screws, 5 M4s, as I said, go into the bulkhead, and then on the other side of that retention, which will be the tube edges there.
So is that
will be 5
lower
M4s.
airframe, is that all one piece, or is there a break point?
There, do you see where my mouse is?
Uh-huh.
Yeah, so from below that line, that's the motor tube, and then that break point upwards until the avionics bay.
So you've
So
got
there's
something
2
kind of
tubes.
that looks like this. Okay.
Yes, yeah. I think your mic might have cut out. I cannot hear you anymore.
How about now?
Yeah, you're good.
Sorry, I hit the mute button.
Oh,
So-
good.
You've got lower airframe right
Yes.
here. Your motor's back here.
Yes.
You've got a bulkhead and a coupler tube right here.
Yes.
So what prevents when the parachute pulls on this section,
Mhm.
what prevents the rocket from just doing this?
Okay, so
And your lower
since
half
that's not-
just plummeting.
since that's not a separation point, we'll be epoxying it in, and then also 5 screws to bulkhead, 5 screws to that upper tube to the coupler.
Ah, so it's not a separation point. So
Yeah,
that whole
so that-
section's one continuous tube. Okay.
It'll be 2 tubes, but epoxied together with that coupler, if that makes sense.
Okay. So epoxy.
Yeah.
Very good.
Yeah,
All right.
our manual doesn't allow for tubes that long. So it'll be,
Ah, okay. Very good.
but
good.
yeah, the coupler will be epoxied so that the tubes will hopefully behave as one piece, and then alongside screws to the bulkhead, screws to that second coupler tube. So,
Okay. Thank you. That helps.
All right.
That alleviates my fears.
okay, good. Yeah, sorry
All
I
right.
didn't get that the first time.
Nope, it's okay. Pretty much we're through everything now. You've got rail buttons.
Yes.
Rail buttons, those are going to be installed. How are you going to install those?
Yeah, so there's gonna be obviously 2 holes drilled in the airframe, one around the center of gravity and one aft.
Mm-hmm.
And then a
Are
big
you going to drill
washer.
into the bulkheads? Are you going to try and get a like a T-nut on the backside, or are you just going to drill through and hope that the screw holds? Or are you going to try and tap it?
T-nuts on the back. So yeah, what we're
Okay.
doing is we have little like wooden inserts that match like the curvature of our inner airframe. And then yeah, T-nuts, and then those will be epoxy to the side.
Okay, very good. Cool. And that pretty much covers it. So do you guys have any questions for me?
I have a question. How long do you think before you'll get it all assembled?
Within the next 2 weeks, I'm hoping to have everything manufactured. Yeah, it's been
Manufactured or assembled?
okay, assembled probably within 2.5 weeks.
Like the first week of June?
Yes,
When are you taking it down?
we leave on hold on, let me pull up my calendar.
It's the 13th, I believe.
Yes, yeah, the 13th.
Cutting it awfully close.
I know. It's not ideal, but we're gonna make it. I'm sure of it.
Are you guys driving or are you flying?
Half of us are driving, half of us are flying.
Okay. And you're going to drive the rocket.
Yes.
Okay. Yeah. So my feedback to you guys is that you guys are behind the game on having your rocket ready to go. Most of the other teams had a fully assembled rocket to show me that had just, hey, we just need to install rail buttons. We need to paint this thing. You guys are pretty far behind the power curve on this one. So don't take that as criticism. Take it hopefully as motivation to get it done. But that I would consider you most likely high risk. You know, that's feedback for you guys. So step it up. Work with John as he's going to be ultimately the flyer record for all this. You know, he has to sign off on it.
Yeah.
So just keep that in mind. And, you know, if he has any questions, work with him. You're going to want to show him, you know, your progress and everything so that he's got peace of mind that you guys are going to be safe out there at Spaceport. Okay.
Yeah. For sure. Yeah.
John, do you have anything to add?
No, I'm comfortable with the design. It's a matter of getting it assembled,
Yep.
manufactured and assembled.
Yeah.
Yep. Totally agree. Okay. So with that, I'm going to stop talking about the rocket. I'm going to start talking more about what to expect out there at Spaceport. I'm glad that you guys have at least about a third of your team who's had experience out there. So you know a little bit about what to expect. But just for everybody's sake, I want to cover some of the high points. Just make sure that when you are traveling out there, especially since you are driving, okay, take your time. Again, I'm going to put my dad hat on. Don't try to overdo it. Communicate with us if something goes wrong. If you get a flat tire, your engine blows, something like that happens. Communicate with us so that we know what's going on. If you're like, hey, we're going to be a day late, we're going to be 2 days late, and we need some help, let us know so that we can make plans and make accommodations for you. Okay. Don't be, you know, like, oh my goodness, we lost the day because we blew a tire and now we got to hurry up and rush and drive through the night. Don't do that. Just communicate with us and we'll work with you. Okay. Also, and just make sure you have a good plan with stops, with breaks, that type of thing for the folks who are traveling. It is a long way from Canada.
Yeah, we're actually like carpooling with another team that's done the drive basically like a lot more times than we have. I think it's like at least 5. We're driving with Carlton John.
Oh, okay.
Yeah. So they already know the ropes and everything. They're taking detours to see some tourist attractions. I think we're just gonna meet them at campsites. But yeah, they have a good plan.
Okay.
Very good. Yeah, definitely take the opportunity, you know, to do some of that with while you have the opportunity. You know, but since you guys are from Canada, you know, just like last year, make sure you guys are bringing your passports or government IDs. There is that border checkpoint between Las Cruces and the vertical launch area. You know, most of the time they don't care, but you don't want to be caught the one time they do. So just make sure you're being conservative on that and you know, just carry that with you at all times. Just like last year, dress and planning for hot weather is extremely important. Just like last year, you know, 115 degrees Fahrenheit, what does that translate to? That's like 50 C. Like that is a real temperature out there. The bad news is that you're going to get out there and because it's dry, it's not going to feel like it's that hot. But it actually is. And so what's happening is your body is evaporating fluids throughout the day and you're getting dehydrated. make sure you take, and my recommendation is the very first day you're going to be out there in the field, take a gallon of water, take 2 liters of water for every single person out there. And then based on your first day of consumption, you can plan your subsequent days after that. But then again, when you actually fly and you're going to be recovering, you're going to be walking out in the field, bring too much water again. Okay. That's what I would recommend. Most of the folks who get in trouble out there are because it happens and they end up in the ambulance because of dehydration. It'll catch up on you, and once you get behind the power curve on that, you know, it's very difficult to catch up. And sometimes if you get too deep, you can't catch up, and you're going to end up in the ambulance. There will be, you know, medics out there and everything like that. So, you know, we'll take care of you out there, but you don't want to be that person. So just I can't foot stomp that enough. Dress appropriately. So most likely, or what works really well out there are long sleeves. It sounds a little bit counterintuitive, but long sleeves that breathe for your shirts. Those are the best things out there. Bring hats with a really wide bill. You can bring ball caps. Those are okay, but it's better if you have like a boonie cap or something that'll keep sun off you for 360 degrees. Sunscreen, sunglasses, all that stuff to protect you from the sun out there. It is extremely hot. It's extremely bright. It's extremely dry. It's extremely dusty. When you're actually out recovering, if you see wildlife out there, assume it is out to get you. You know, there's rattlesnakes. I've never seen one. I've been out there before, but they are out there. There's ants. You will probably see those. Steer clear of them. And then there's all sorts of other little nasty little bad things that are all out there. So if you see it, just be prepared and, you know, steer clear. Boots are an absolute necessity. Don't go leave the vertical launch area or try to recover anything without boots. I'll tell you a little story. Last year, I had thick boots on. I came prepared. There are thorns out there that are like 2 to 3 inches long. There was one that was buried and I stepped on it and it went through my 1.5 steel or it went through the 1.5 of the bottom of my foot, of my the sole of my shoe, and it went into the bottom of my foot. Had I been wearing a tennis shoe, that thing probably would have gone through my foot. So absolute must, you have to have good boots out there and long pants. The person who wears tennis shoes and shorts is probably going to get yelled at by ESRA. Not because they're mad at you, but because they don't want you to get hurt. Okay, so that's another big thing to foot stomp out there. You guys have accommodations for where you're going to stay, correct? Where y'all staying?
The dorms, like the New Mexico State University dorms.
Okay, very good. Just be aware of, you know, be respectful of those dorms. Like I know you guys are behind the power curve on manufacturing, so it's generally bad practice to do things like painting and spray painting inside the dorms. You know, I would caution you from building rocket motors in the dorms. We've had several incidents in the past couple of years, and you don't want that. You don't want that bill. So I highly recommend you can do all the prep you want in your dorm, but you know, the energetics are probably best left for the field. My personal opinion. Everybody's got their TRA membership, TRA numbers. Everybody?
Yeah.
Okay. That is a mandatory thing. Like they're not going to let you fly and not going to let you be out there. That helps. That's an insurance thing. So everybody's got to have that. And then we've already talked about your flyer record. This year is going to be a little bit different when it comes to the VLA setup. Last year you were kind of on your own to provide chairs and tables and tents. This year you've got tables and tents for you. So they're going to have big tents out there. They'll have student designated areas for where you're going to be at. They'll have a table for you, but you're still on the hook for chairs. So just be aware of that. But that's a nice add for this year because last year we had a couple teams that didn't have a tent and were hurting out there. Just like last year when we do the check-in, expect at least the first 2 days, and then you know the first couple flying days, it's going to be long lines. And it's gonna be a lot of waiting. So just be prepared for that. It's going to take, you got like 100 and 110 teams this year that are trying to get in there and get registered. We're going to do our best to get everybody in and get them to process quickly. It's going to be very busy. That first day, the biggest two things are getting registered, getting checked in, and then getting your safety check. Those are the things you want to do. If you have the time, you also want to make sure you get to DaVinci, get your radio frequencies, and you also want to get your team photo and then set up for your poster competition. Okay. Just like last year, when you get out to the vertical launch area for flying, again, long lines. Those gates are going to open in the morning, but it's going to be stacked up about a mile or two of cars just waiting to get in the morning. So it's going to be wait. It's going to be a very long wait. So just be ready for that. But once things get going, you know, it's bang, bang, bang. So in the mornings, it's first come, first serve. So as soon as you're ready and you get you get through your RSO check, and then you get through your frequency check, and you get your slot. I think it's up to 30 pads this year. So they're going to go in waves just like last year. So the first 30 teams through are going to fill up those slots. And once the 30th team comes in and fills up that last slot, the first wave is going to move on out there and things are going to move bang, bang, bang. Make sure you got your flyer record with you and make sure everything is ready to roll. Okay. And then once you get out there, you'll get the rocket up. Only the flyer record and one team member are going to be allowed to actually be at the rocket when the igniter is inserted. Speaking of igniters, so what is your igniter plan?
Dual-headed boron igniter.
Are you buying that? Are you making that?
Yes, buying it.
Buying it. Okay. Very good. Good answer.
An extra dowel, like an 1/8-inch dowel in
Yes.
case the first one doesn't work.
Yes, yeah.
Just be prepared for those contingencies. You know, it's going to be very exciting once you get into the wave. Once you get up there, team will go out there. You'll put the rocket up. Once it's on, everybody's going to head back to the bleachers, and it's going to be very busy. Pay attention because they're going to go bang, 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 you know, really quick because they want to get the next wave going. So remember, you're going to need to give them a thumbs up that yes, we are ready to go. And then a second thumbs up of yes, we are receiving telemetry. There are going to be 2 telemetry checks, one at the pad before you go back, and then a second one when you're at the bleachers. Okay, both of those are necessary before they'll fly. If they're calling your name and they're looking for you and you're not paying attention, you're going to get missed and they're going to bypass you. So that's just my advice to you guys. All right, I've been yapping for a while. Do you guys have any questions for me? I've pretty much covered all my talking points.
I just had one question. So last year for recovery training, that was sent out by Ezra like early on. So we all did our recovery training and then just had to grab like our passes at check-in or registration. Is that going to change this year? Because we haven't received like any like recovery training ahead. So, or is recovery training going to be provided on site? Like, I'm unsure what the.
That's a good question. I don't actually know the answer to that one. I would assume it's going to be just like last year for
Okay.
at least like the check-in and the procedures.
Right.
So expect to pick up a backpack. You're not going to be cleared out there. You'll have to talk in with the walkie-talkie to the range safety officer and range control as you go out there and pick it up. It'll pretty much be the same procedures because they have that map and they're tracking you on GPS where you guys are and all that kind of good stuff.
Yeah, but I'm talking about like the original like last year there was a video recovery training that was sent out that needed to be done by all the members who would be actually going out onto to recover the rocket before even like competition. So I don't know if that's something that's still being done this year or if we're going to be kind of just doing recovery training like on site.
Yeah. I don't know.
Yeah,
That's
no
a good
worries.
question to ask. Yeah, I would ask them.
Yeah.
Either post on the site and ask about it. That's what
Okay.
I would say. That's probably the best way to do it. But good question. What other questions do you guys have?
I think we're good. Yeah, besides manufacturing, getting a go, it's sort of hard because I'm working in Cambridge and then commuting on the weekends to build. So yeah, we'll get it done.
Roger that. Okay. John, do you have anything you want to say?
Not anything more. Nope. Just get
Okay.
it done.
Yeah, we're gonna get it done. Don't if I lose my sanity along the way, I'll still get it done.
Alrighty. You guys are, you know, I liked your design. You guys have had good reports all year. I want you guys to get out there and compete. So just like John said, get it done. I'm excited for you guys. I want to see you out there. I love to meet you in person. I think you're a good team. You're not one of the teams that's been like a major concern for us this year. There have been several of those. So that's my feedback to you. So, all right, if you guys don't have anything else, I'll sign off. We've been going for about an hour and 10 minutes.
One more question.
Go ahead.
Do you know if we are gonna get feedback on the technical report, or if that's just gonna get, like, we're gonna get the score when the scores come out, or if there's gonna be like feedback on it?
So I'm actually one of the judges. I don't know if I'll be your judge, but I'll be one of the judges for the technical reports, and that hasn't been done yet since those just came through. They're assigning those out to judges now. I don't know if you will get feedback, but I know that process is in the works right now.
Okay, yeah, because like looking at previous years, I don't think we've gotten them like even after comp, like there's no feedback, it's just a score. And because they're like the most detailed ones, it'd be nice to get feedback just for future years. So like, or like on some of the more detailed stuff that we did. But just
Yep.
If you know if that's a thing that's gonna happen later on, or
You know what I would do? I would post that to the site and ask about that. That way
I
you
think
bring
we-
attention to it, and then they maybe can add it to their procedures.
yeah, I saw at least one post about that. Someone already asked it, but yeah, hopefully that'd be good to have.
But if then you post about it, and then a couple other people post about it, then you start creating critical mass and like, oh, this maybe thing is something we should do. So,
Okay, sounds good.
Yeah,
you.
thank you.
Okay, thanks. See you in a month.
Bye. Oh,
all
yeah.
right, team. Y'all have a good night. Take care.
You
Bye.
too.
Yeah.